Welcome to part 2 on exponential functions. In the simplest form, an exponential function has some constant, a number, with a variable as an exponent. So we've talked about what that looks like. We have f of x equals b, the base, raised to the x power. With scalars, the function could look like f of x equals a times the base, b, raised to the x power plus c. It's important to note that the plus c at the end would shift the function either upwards or downwards based on whether c is greater than 0, it would shift it up, and if c was less than 0, it would shift the function down. With respect to this new notation for the function, a defines the y-intercept. So if a is some number other than 1, a would, say 3, would make at x equals 0 the function cross at 3 instead of 1 like we saw in the previous video. B defines the ratio or growth and decay rate. Now you may have heard of the doubling time or exponential growth or something doubles within so many hours. Kind of like bread dough. If you let it raise for an hour, it's supposed to double in size. So if it doubles by some amount, you would say the base is 2. The growth rate could also be something where if you're increasing, say, a percentage rate for a salary by 5% per year, you would say your base B is 1.05 because you're keeping the original salary, but then you're increasing it by 0.05 each year, or whatever your increment is. C defines the shift up or down, and that's what we talked about here. So the domain of a standard exponential function is R. We can also define this, all real numbers, as negative infinity to infinity in interval notation, and the range is from 0 to infinity. It's important to note that there exists a horizontal asymptote at y equals 0. So if I were to draw the horizontal asymptote in, it would be along the horizontal or x-axis. But this may shift up or down depending on c. Now remember, if you add c, it would shift it up, and if you subtract c, it would shift it down. So if we want to talk about f of x equals b to the x, where b is greater than 1, we will have a function that has exponential growth. And you will always see the function crossing at the point on the y-axis 0, 1. This is exponential growth. Now, if you had a function f of x equals b to the x, where b is between 0 and 1, this would be fractions of a whole number, so like 1/2, 1/3, 1/4, etc., you would get exponential decay, where the function approaches the horizontal asymptote at y equals 0 as the function values of x get bigger and bigger. This is also crossing the y-axis at the point 0, 1. But this is exponential decay.